Hello from Smokeless Chimney. We worked with baseline testing this week. We're trying to find the most stable light source. I ran the alpha unit for about 90 hours before the power went out for meter replacement. And it appears we have a correlation between the temperature of the LED and the output of the LED. This video will be to present the facts supporting this hypothesis. The first graph I want to present to you, I have a yellow line in it's a temperature chart, and I'm having a lot of noise problems, but you can see out there that we get up to 150 degrees. Our June, July days are reaching 80 degrees Fahrenheit. And there's no heat coming out of the chimney right now, just a baseline testing. So I see a correlation between the temperature of the LED and the color shift and the opacity. This temperature offset may be corrected for because it's rather consistent. And it's something I see in the data. I tell people that when I see something in the data, the hair stands up on the back of my neck, and it really means something. It doesn't mean I can correct it right away with a correlation, but we can work in that direction. In the chart I'm showing now, it's from 50 hours to 90 hours. The temperature is rather clean in the yellow line. You can see that when the temperature dips to 100 or so, there's an increase of about 4 or 5 in the color shift and a decline or a downshift in the opacity reading by about 1%. These aren't that big. However, if we can correct for it, we can get an even more stable light reading. And it's pretty clear to me that when the temperature of the LED goes really high, we're gonna get a change in the color shift, and we're also gonna get a change in the opacity. So if we know what our temperature of our LED is, we can correct for it, and we'll come up with a conversion factor to say, if it's 150, we're gonna assume that the color shift is shifted up 2 to 4, and the opacity is shifted down 2 to 4. It's just one of the things you need to do to make sure your system is as stable as you can get it. I requested some information from the manufacturer, and they gave me this fuzzy spreadsheet. The light we're using is the second one down, the 3 watt, 2800 to 3200K. I'm using it at a slightly lower voltage and lower amperage, roughly a 1/4 watt. But that's to keep it from heating up, because we know now that if a LED heats up, 1, it alters the light output, and 2, it diminishes the light output over time. So you're basically sacrificing the LED if you're getting it too hot. Let's dig a little deeper into this. Let's look at the independent diode responses. This is a 90-hour run of the system. It's rather stable. However, you can see that when the temperature goes down, the output of the LED goes up. The output of the diode receiving the LED goes up, indicating that the LED is getting brighter.
Winter chills us to the bone, but smokeless chimney